So thank you very much for joining us. This is a section about an introduction to Strimzi, so a project about running Apache Kafka on Kubernetes. I am here, I am Paolo Patierno, and I am with Jakub Scholz. We are both maintainers of the Strimzi project, and we are going to talk about this project and having an introduction about it. So first of all, let's talk about Kafka. So Kafka is an open source project created by LinkedIn, and it's defined as a publish-subscribe messaging system at first, but during the years, these definitions evolved somehow, and today is really used as a data streaming platform. But at the end, Kafka is a distributed, highly scalable and fault-tolerant commit log. But let's say that Kafka, it's not just the broker, so the component that is in charge to handle all the messages and exchanging the messages between the clients, so the consumer and the producers. But Kafka is really a broader ecosystem. So we have here on the right-hand side, you can see, for example, Kafka Connect, which is a framework used for moving data between different systems, like, for example, from a database to another using Kafka as a system for exchanging the data. Or, for example, there is Mirror Maker in order to mirroring data between two different Kafka clusters. There are also different APIs for the clients. So a kind of low-level consumer and producer API for receiving and sending messages, and even the Strimzi API that allows to develop some more complex applications for analytics on real data streaming data. Other than that, there are, of course, even third-party tools which are not part of the upstream Kafka community, but are used in order to interact with Kafka and using a Kafka cluster as well. Now, why we are going to talk about running Kafka on Kubernetes? Why running Kafka on Kubernetes fits pretty well? First of all, Kafka is a messaging system distributed by nature, and in most of the cases, even all the workloads and the application using Kafka are the same, so distributed and scalable. On the other side, we have Kubernetes. Kubernetes define a great abstraction in order to run your software everywhere. So you can run Kubernetes on bare metal or in any cloud providers, like, for example, Amazon, Azure, Google, and so on. And in that case, you can just move your application running from one cloud provider to the other or on bare metal thanks to Kubernetes. So it enables to develop some cloud native application, right? But why, if you have your Kubernetes knowledge, you have to learn more about Kafka? It will be great using your Kubernetes knowledge to run Kafka on Kubernetes. This is the reason why we have Strimzi today. So Strimzi is an open source project, and it's focusing on running Kafka on Kubernetes, providing all the container images that you need for Kafka, for Zookeeper, and for all the other components that are part of the Strimzi suite, let me say. And it's based on some operators. We will see more about that during the demo with Jakub. Using these operators, you are able to deploy, handling, and configure the Kafka clusters and all the other Kafka entities around the cluster. So it provides a Kubernetes native experience. So you can handle your Kafka cluster, the entities in Kafka, but using your Kubernetes knowledge. So not only the Kafka cluster, as you already mentioned, but even, for example, the users, the topics, and all the other kind of stuff that we already saw are part of the Kafka ecosystem. And the great thing is that Strimzi is a sandbox project in the CNCF since 1 year, more or less now. When I mentioned a Kubernetes experience, I mean that as today, who use Kubernetes can handle pods, deployments, stateful set as a native Kubernetes resources. It's quite the same using Strimzi for Kafka. So it means that extending Kubernetes using a custom resource definitions, some custom resource definitions, it's possible having Kafka as a native resource in Kubernetes. So you have your resource of kind Kafka. You can describe your cluster with the old information, and as well as for all the other components. So you have Kafka user and Kafka topics for handling users and topics in the cluster, but even talking about Kafka Connect and for deploying your Kafka Connect cluster, you can use the Kafka Connect and Kafka Connector custom resource for configuring and running your connectors in Kafka. At the same time, there is a Kafka bridge resource for running a HTTP bridge if you want to allow HTTP client to access the Kafka cluster. Even for mirroring, we have a couple of resources for running Kafka Mirror Maker and Mirror Maker 2. And finally, because Strimzi supports the integration with cruise control, it's not possible to do a total rebalance of your cluster using simply a Kafka rebalance resource. At this point, I will hand over to Jakub in order to show us what I just said.
Thanks, Paolo. Let me share my screen from which I will show you the demo. And I'm here already connected to my Kubernetes cluster. Right now, there are no pods running. And in this demo, I will show you how Strimzi makes it easy to run Kafka on Kubernetes. If you are not familiar with the operator pattern, which Strimzi is using, then the first thing you will always need to do is to deploy the operator. In our case, there are several ways how you can do it. Right now, I'm going to just use the installation script or YAML file from our website. And that will kind of automatically install all the Kubernetes resources which we need. So all I need to do is kubectl apply on the URL. And there are also other options how you can install it. You can, for example, use Helm charts. You can use operatorhub.io, or you can really just download the YAML files from our GitHub website or GitHub project and use them locally. As you can see, the installation really just installs the expected resources. There are some custom resource definitions. There are some RBAC files. There is some service account. And then there's, of course, the deployment, which is how the operator is running. So we can see that now I have the cluster operator pod running in my namespace. And it's now basically waiting for me to create some custom resource, which would contain the definition of the Kafka cluster, which we want the operator to deploy. I have one very simple here prepared to show you the structure. You can see that it's our own API version. It's kind Kafka. And inside, you really have the blueprint for deploying the Kafka cluster. So it specifies what kind of Kafka version it should be using, how many broker nodes we want to have, what should be the listeners, what should be the configuration, what kind of storage should be used. Then it also shows the same for the Zookeeper configuration and so on. This resource is fairly simple. I have here one more slightly bit more complex, which I will use in the demo, where you can see I have more things which are more to kind of prepare your cluster for the production and make it more production ready and resilient. So for example, I configure some resources, I configure some Java options, how to handle the memory. I also configure the listeners, including things such as encryption, authentication, or authorization. I can configure the Prometheus metrics, and so on and so on. So we really support everything what you would need for your production Kafka cluster deployment, and that can be all described in this simple YAML file. And all we need to do with it is to do kubectl apply. And that will create this resource inside Kubernetes, and the operator will see it and will start deploying the Kafka cluster. So when I do now kubectl get pods and watch for them. You can see that it's already creating the zookeeper pods. So if you know a bit about Kafka, you know that it's at least for the time being still using zookeeper to kind of store some configuration, do some log management, bootstrap the Kafka brokers. So we first need to deploy the zookeeper cluster. We have to wait for the zookeeper nodes to get ready to kind of get the working zookeeper cluster. And when they are ready, the operator will automatically continue with deploying the Kafka brokers. So any second now, we should see the pods for the brokers to be created. And we can see that we have 3 pods now starting. And again, the Kafka nodes, Kafka brokers, they will use the zookeeper cluster and they will form their own cluster. And then once they are ready, we will deploy 2 more things. One of them is another operator, which is used to manage the topics and users for this Kafka cluster. And then we also deploy the Kafka exporter, which is exporting some additional metrics for Prometheus monitoring, which are not part of Kafka out of the box. In this demo, I'm really showing just a few of the resources which we support. But as already mentioned by Paolo, in the same way, you can really deploy all the Kafka components. We support Kafka Connect for integration with other systems, Kafka Mirror Maker 1 and 2 for mirroring and kind of disaster recovery. We have an HTTP bridge or proxy for proxying Kafka protocol to HTTP and so on. There's not really enough time to show that in this demo, but the principle of deploying them would be exactly the same. So what I can see here is that the exporter, which was the last pod, is now ready. And when I do kubectl get Kafka YAML, I can see in the status of the custom resource that the cluster is now deployed and ready. And I can also get here the addresses to the different listeners which I configured there. So now when we have the Kafka cluster running, we should probably go on and deploy some application, right? And in Kafka, the applications will be basically always producing or consuming messages from some topics. And because we have the cluster set up, including security, we will also need some user to connect and authenticate. And you can really handle a lot of these things by some Kafka commands and the Kafka utilities. But what we do here in Strimzi is that we provide another set of custom resources for them. So this is, for example, a Kafka user resource, which you can use to create a user for your cluster. Here in my case, I specified authentication. I will use TLS client authentication using certificates, but there are some other options as well. And I will also specify all the ACL rules which this user should automatically get. What I'm using here is really having the users defined and managed locally within the Kafka cluster, but we also support different authentication and authorization methods which allow you to manage these centrally. So you can, for example, use OAuth for authentication and authorization, or you can use Open Policy Agent for authorization as well. Now, again, all I need to do is to apply this resource. And what the operator will do in this case is it will create a secret, which is called my user, which is the name of the user I just created. And the secret will have the TLS certificates, which can be used for the authentication when the user will be used by some clients. And I can do exactly the same with topic. So there's a Kafka topic resource for that. It's called my topic in this case. You can see that I'm really good at making interesting names for the things. It has 12 partitions and 3 replicas, and I have here some additional configuration. So you can really configure everything through this resource. And to create it, I can really just apply it. And one of the big advantages of having these resources is that they are just YAMLs similarly to your application, which will be using the Kafka cluster, and they can be easily stored inside GitHub, for example, and you can use some GitOps tools to have them automatically deployed into the clusters and so on. So now we have Kafka cluster, we have our user and our topic. So all we need to do is to deploy the application. And I have here really just a simple hello world application. It's really just 2 deployments. One is a consumer and producer, and they are sending some dummy hello world messages. Because we have the user operator which created a secret for the user, I can really just mount the secret into the pods to use it for the authentication. So I do not need to do anything special to set up the authentication here. So now we can deploy it, and we should see the pods running now. And let's make sure that they actually connected and are working. Let's check the logs for the consumer. And you can see that the consumer is getting some hello world messages. The producer really just sends every second a message, and the consumer is just consuming that. And as I said, Strimzi is really ready for the production deployment. So for example, part of what I did includes all the things for Prometheus monitoring. So I can just go to my Grafana and check the Kafka dashboard, which will show how many brokers I have, how many partitions. It will show the throughput, which in my case, it's really small from the Hello World application, but everything is basically here out of the box provided. We have dashboards for all the components and for all the operators. So that's all available and can be easily configured. So that's it for the demo, and back to you, Paolo.
So thank you, Jakub. Great demo. Let me share again my screen. So this. Okay, so as already mentioned by Jakub, Strimzi provides a lot of features. Of course, Jakub, for the time that we had, showed just a few of them. But as you can see here, there are a lot of things that you can change and configure in with Strimzi about your Kafka cluster. You can scale up and scale down easily your cluster, just changing the number of replicas in your Kafka resource. You can use affinity and toleration in order to specify in which nodes you want to the Kafka brokers pod to be deployed. Or for example, you can do mirroring using Kafka Connect, using OAuth for the authorization and authentication part, the cruise control for cluster balancing. As well as we have integration with Prometheus and Grafana, so for providing metrics. We use secrets, for example, for storing credentials and certificates. We have support for encryption, so you can encrypt the traffic between the clients and the Kafka brokers, but even the traffic inside the cluster itself. So there are a bunch of features, as you can see from this slide, that Strimzi provide just out of the box. Other than providing these features itself, Strimzi is really well integrated with a bunch of other projects coming from CNCF. So for sure Kubernetes, because we are talking about that, even Helm, because we have a way for deploying the Strimzi operator using the Helm charts. There is support for tracing, so for having tracing information about the messages exchanged between the clients using the Kafka brokers. So Jaeger and Open Tracing fit really well here. Of course, Prometheus integration, FluentDS support for Kafka as well, the Open Policy Agent for specifying authentication and authorization rules for your consumer and producer in order to access the topics. And even, for example, with CADA, which is one of the latest project joining the CNCF, which is about auto-scaling application. And there is a scaler for Kafka, and you can even deploy Kafka using Strimzi, so it's well integrated with CADA as well. So there are a bunch of projects from CNCF from this point of view. Now, a kind of call to action for the community. How can you engage with the community, with the Strimzi community? You can just download Strimzi and try it yourself. You can maybe, I don't know, find some bugs and you can submit the bugs, so opening a GitHub issue about the bug. Or if you have a fix for that bug, or you have a feature that you would like to add to Strimzi, you can submit your code, so you can open a pull request, and we as maintainers will be really happy to review and approve and merge, of course. You can even help on the documentation, so you can maybe fix some typos or make clearer the documentation where it's not, translate the documentation in other languages, but you can even engage with the community in our chat room. There is a chat room, a Strimzi chat room in the CNCF Slack workspace. You can even follow us on Strimzi, where we tweet about all the news about Strimzi, new blog posts, new features, new release, and so on. But even you can help with spreading the word. So if you like to have a presentation to a conference, to a meetup, or even writing an article or a blog post about Strimzi, it would be great. And if you want to have a place for blogging about that, you can even blog with us. So you can use our official website in order to write your own blog posts, your ideas, and how you are using Strimzi. So these are the ways for reaching the community. The website, so strimzi.io, the GitHub repo, which is a Strimzi organization where there are all the components in the Strimzi ecosystem, so the operators, the bridge, the OAuth library, some client examples, and so on. Our Twitter account, the chat room, as you already mentioned, on the CNCF Slack workspace, so the Strimzi room. And there is, of course, a mailing list if you prefer to send mails in order to get help or providing your ideas or engage with us in any way. So that's all from us. So really, thank you very much for joining us. And I really hope that you are going to use Strimzi and try it.
Okay, thanks Jakub and Paolo for the great talk. Now let's start the Q&A session. Jakub and Paolo, you can take a look at the Q&A tab in Zoom and answer any questions you want. Thank you.
Thanks a lot. So we got there already some questions. So we can have a look at them. The first one was, why is Strimzi not a project in Apache Kafka? And yeah, I think Strimzi really stands in between Apache Kafka and Kubernetes, because it's basically has a big relationship to Kubernetes on one side, and then obviously big relationship to Kafka on the other side. And if you look at the history of the Apache Kafka project, there's a lot of focus on the core Kafka and its activities. And there are a lot of projects which are not really part of the Apache Kafka project itself, but relate closely to Kafka. For example, it would be all the different Kafka clients for the other programming languages than Java. It would be, for example, the different UIs or the things like, I don't know, cruise control for cluster balancing. And that allows the Kafka community to really focus on its basically core business, on making the Kafka clusters great and Kafka Connect. Yeah, that's why Strimzi is kind of a separate project, which is part of the CNCF Foundation as a sandbox project. And we really kind of leverage there our relationship to Kubernetes, basically. then the next question was, what's the benchmark difference between directly run Kafka and Kafka run on Kubernetes by using Strimzi? And I think that's, again, a great question. But the answer is a bit hard because a lot of that depends on your infrastructure. It a lot depends, for example, how the networking on your Kubernetes cluster is configured and how it compares to the networking of your, for example, VMs or bare metal infrastructure without Kubernetes. If the cluster configuration and the networking and the I/O and so on is really on a good level, then actually there might not be such a big difference. But in some cases, kind of you see some performance degradation because, for example, the network is a bit slower and there is some overhead. There would be also a difference. So when you access the Kafka running inside of Kubernetes with applications from outside of Kubernetes, then obviously you would kind of need, for example, load balancers or something like that to expose the Kafka cluster. And that kind of in the communication basically adds some additional hops which the connections have to travel through. So that may, for example, slightly increase the latency for the Kafka clients. But in general, it depends a lot on the environment.
Yeah, and I would like just to add that if you already have some application running on in the clouds, so you have some native cloud applications running already on Kubernetes, you have some workloads on Kubernetes, and you need to use Kafka. I think that in this case, Strimzi fits pretty well because you can run Kafka in the same Kubernetes cluster where you have your applications. While, as Jakub said, when your applications are outside, maybe you can see maybe some differences on that side. But for a native, for a cloud native development, it should be really a great choice running the Kafka cluster in the same Kubernetes cluster where your applications are running.
Okay, are there any other questions from anyone? So,
okay. Yeah, here you go.
There's one more question, which I think still should have time to answer. Will Strimzi support dashboard for enabling users to configure brokers easily? And the answer there is definitely yes. We are working on it. If you go to the Strimzi GitHub repository, you will find their repository called Strimzi-UI, which is where we are starting to develop the dashboard. And on the CNCF Slack, we have also now a new channel, Strimzi-UI-dev. If you, for example, want to join the development of the UI dashboard and help with that, then you can definitely join there and let us know. And yeah, we are definitely working on this, and I hope that soon the first versions will be available.
Yeah, that's in an early stage. We just started to take a look at some proposals, but it would be great having feedback on that.
The next question is whether Strimzi supports all the different versions of Kafka. Paolo, do you want to answer it, or should I do it?
I can do that if you want. So Strimzi in general supports the latest 2 versions of Kafka. So for example, now we have Kafka 2.5 and 2.4 supported. That's the way that we support Kafka. And when a new version of Strimzi comes out, one of them is just dropped, and in order to have a kind of way for upgrading your cluster from one Kafka versions to the other.
I would maybe add the reason for this. The thing is that Kafka is still evolving quite heavily, and there are a lot of new features which we want to use. but it's quite hard to support the new versions with the new features and the old versions with the old features and so on. So that would be really a lot of effort for testing and development. So that's why we really focus mainly on the latest versions, and we try to support the new features which are in these new versions as well.